Friends, and welcome back to the next session of our fast track structure analysis course, guys. Basically, so guys, due to some medical emergency, I was not able to take the classes in last few days, right? So there is no problem. We will continue over this particular series which we have started, right? Which is based upon the structure analysis, and I think we have completed the 5 lectures which is related to the different topic like static animacy, kinematic animacy, like problems on static and kinematic animacy. So these type of topic we have already covered, as well as we have discussed about the method of joint and method of section, how to solve any kind of problem or any kind of truss, which is basically determinate truss, by using the method of joint or method of section. Now in our today class, what we have to do basically, we need to discuss the problem based upon the analysis of determinate truss part. We need to understand how to solve the question which is related to the determinate truss part by using the method of joint or method of section, right? So let's start this particular session, guys. Let's start it. So these are the topic which we want to cover today. These are the topic which we want to cover today, and these are basically our methods which we have already discussed in our previous class, which is basically the method of joint and method of section. Let me give you a very quickly an overview, or you can say that and quick recap of this particular methods. What are these basically? So guys, do you remember we have two type of equilibrium equation? One is static equilibrium equation and second one is joint equilibrium equation, correct? Now guys, static equilibrium equation are basically summation fx0, summation fy0 and summation mz0. Similarly, we have two joint equilibrium equation which are basically summation fx0 and summation fy is equal to 0. Summation mz is equal to 0 is not available at any of the truss joint. Why? Because whatever member you have, so the forces in these member are basically congruent at the particular joint, and if these are basically congruent at a particular joint, then you are not able to write down summation mz0 by using these force members or these truss members, right? So that's why guys, we have only two joint equilibrium equation. One is summation fx0 and summation fy is equal to 0. Okay sir. Now the second thing is, we are trying to solve the determinate truss in which the static indeterminacy is equal to 0. If it is 0, that it means we are able to analyze the truss, whether it is external reaction or internal reaction, by using the equilibrium equation alone. That is the meaning of ds is equal to 0 or determinate truss. Now guys, we have basically two methods. One is method of joint and second is method of section. So if we talk about method of joint, so in method of joint guys, we need to use the static equilibrium equation to find out the external support reaction, and if you want to find out the internal forces of the member, so you need to consider individual joint and try to solve the member which is present at that particular joint by using the joint equilibrium equation, which is basically summation fx0 and summation fy is equal to 0. That means we are trying to use the joint equilibrium equation to find out the internal reaction of the members. Okay sir. Now if we come to the second portion, which is basically the method of section. So in case of method of section guys, again we are trying to use the static equilibrium equation to find out the external support reaction, and if you want to find out the internal reaction also, you need to use the same equations, which is basically static equilibrium equation, and this is the basic difference between these two methods. In first method, we are using joint equilibrium equation to find out internal reaction, and in second method we are trying to use the static equilibrium equation to find out the internal reaction, correct? Okay sir. Now guys, there is one more point with respect to the method of section. You know that we need to cut the section in a structure or in a truss where we want to find out the members or forces in the members basically, right? So this particular section can be any of the it can be any of the shape, like vertical or like horizontal, or you can say that zigzag, right? It may be curved also, right? It may be like half circle also. Whatever shape you want to draw, you can draw it. There is no problem. But there is one condition, and that condition says if you cut the members by using a section, that in such condition or in such case, maximum 3 unknown member can be cut by that particular section, because we have 3 static equilibrium equation by which we can solve 3 unknown only at a time. That is the reason. Clear? So this is the basic overview of, or you can say that a small recap about this particular methods which we have discussed in our previous class, which is method of joint and method of section. So let us continue our class, guys, and let us understand the problem based upon this. So today our topic is to solve the problem related to the method of joint and method of section. So guys, if you want to get the PDF of this particular class, you can join my Telegram also, right, where you will get the PDF, and you can search my Telegram channel, which is Krishna Yadav Sir PW, right? Okay, let's move quickly on the problem part. So this is the first question which we have. What we need to do, guys, over here, we need to find out the force in member AB. Kindly see this. You need to find out the force in this particular member, right? What should be the force in this particular member? We need to do this. And this is the truss which is given to us. Okay. So guys, you can see here, we need to find out the force in a single member, which is AB member. But if you want to find out this particular member, what you need to do, you need to consider this particular joint, right? And try to find out the external support reaction first. After finding the external support reaction, it is very easy to get the answer for AB part. Clear? Okay, sir. So let's do it. So let us write down the external support reaction first. You can see here, guys, what is this? This is basically VB, and this one is HB reaction. Okay. Similarly, we have, let us consider this particular support is D. So what we will write, this is VD and this one is HD. Okay, sir. Now guys, what I will do, first I will write summation moment about this particular point D is equal to 0, so that we can get the value of VB reaction. Okay, let us write it down. Summation moment about D is equal to 0. If we write like this, so VB into how much? VB into how much? This is 16 plus 10 into how much? 4 plus 4, that is 8. So 10 into 8, and it is equal to 0. So let us calculate the value of VB. How much it is? It is minus 5 kilonewton. Minus 5 kilonewton. What it indicate? If you are writing minus 5 kilonewton, what it indicate? Any one of you who can tell me what it indicate exactly? Minus 5 kilonewton means what? It means, listen very carefully, it means whatever direction you have considered for VB, right? Whatever direction you have considered for VB, that is wrong, right? And your answer which you are getting is negative 5. That means you need to change the direction of VB basically. That means VB is trying to apply in the downward direction. That is the meaning of negative. It does not mean about the compression or tension behavior. Clear? Okay, sir. So we know the value of VB, and it is equal to how much? Minus 5 kilonewton. Now let us consider this particular point as C. Let us consider this particular point as C. And let us take moment at C is equal to 0. We can write it, guys. Why it is so? Because this particular part can rotate about this particular point individually without disturbing the other one, right? That's why we are able to write down MC is equal to 0 easily at this particular junction. Okay, so let us write down MC is equal to how much? It is 0. If MC is equal to 0, if MC is equal to 0, we can write here VB into this distance. How much it is? It is 8 meter, right? Which is in clockwise direction. This HB into 8 meter, but it is in anti-clockwise direction. What about 10? 10 will not produce any kind of moment about point C. That's why, guys, we will not write it, and it should be equal to 0. So VB is equal to how much? It is equal to HB. So we can write here HB is how much? It is minus 5 kilonewton again, right? That means VB and HB value is same. VB and HB is completely same. Now what we will do, guys, We'll try to take the joint B directly. Okay, let us draw the joint B. And this is our FAB. And what about this one? This is the one vertical member, right? Let us consider F, right? And this particular angle is theta. And how much it is? If this is 8 meter, this is 8 meter, that means it is 45 degree. So we can write here theta is equal to 45 degree. What is this vertical reaction? It is VB. This one HB. Clear? Now what I will do, guys, I will take the summation fx is equal to 0 at point B. At point B, summation fx is equal to 0. So can I write it down? HB plus FAB cos 45 degree. HB plus FAB cos 45 degree, right? And I think there is no other component of the forces in the horizontal direction. So we can write it, it is equal to 0. So what is the value of HB we have? It is minus 5, sir. Minus 5 plus FAB multiplied by cos 45 is 1 by root 2. And it should be equal to how much? It is equal to 0. So FAB is equal to how much? It is 5 root 2 kilonewton. 5 root 2 kilonewton. 5 root 2 kilonewton. I hope each and everyone or all of you are able to understand this particular problem very well. Please write down, guys, any query regarding this particular question. Please write down any query regarding this particular question you have. Any query regarding this particular problem? Crystal clear? Okay. Let's move to the next one. Let's move to the next one. There is a truss which is shown in the figure. Members are of equal cross section, right, A, and the same modulus of elasticity E. A vertical force P is applied at point C. Okay. The force in member AB of the truss is. You need to find out what is the force in member AB. And again, I think we need to do the same thing. Okay. Let's understand, guys. So this particular angle is how much? Again, you can find it out. It is 45 degree. Why it is so? You can see, guys, this particular vertical height is how much? It is L, which is already written over here. And this horizontal distance is also how much? It is L. Correct? If both the value is L, then definitely this particular angle is how much? It is 45 degree. 45 degree. 45 degree. Okay. Now, you know that, guys, if this particular truss is symmetrical truss or symmetry about one vertical axis, so you can understand this thing. This particular force will be how much? It is P by 2. And this vertical force is how much? It is again P by 2. Clear? P by 2. Now let us take directly joint B. Let us draw joint B directly. So this particular force is how much? It is P by 2. This force is P by 2. Let us consider there is one force. Let us write it F, and this angle is 45 degree, and this is basically FAB. This one is FAB. Okay, sir. Now what I will do, guys, I will write down the summation Fy is equal to 0. So F sine 45 degree plus P by 2 is equal to 0. So F is equal to how much? Minus P by 2. We'll write like this. F divided by root 2 is equal to minus P by 2. Now we can cancel it. It will become minus P by root 2. So the force F is equal to minus P by root 2. Okay, sir. Next thing is, we need to write down the summation fx is equal to 0 also. Summation fx is equal to 0. That means F minus of FAB minus of F cos 45 degree is equal to 0. Correct? So FAB is equal to minus F cos 45 degree. Clear? Now what is the value of F? It is minus P by root 2. So let us place it. Minus minus will become plus. So plus P by root 2 multiplied by 1 by root 2. So it will become P by 2. So the answer is P by 2 basically for this particular question, and that's why C is the correct answer for the problem. C is the answer for this particular question. Any doubt guys in this particular problem? If you have, please write down or mention in the comment. Any query, any doubt related to this particular part of the question? Crystal clear? Crystal clear? Okay, so let's move to the next question. Let's solve this. So determine the force in member AC. You need to find out the force in member AC and comment upon the nature of this particular force, whether it's compression or it is tension. You need to write it down. So right now guys, you can see this particular structure. They are trying to mention one dotted line over here, which is nothing as basically a section, right? So they have already mentioned you have to use the method of section, and the section is already given to us. Now it is your choice whether you are taking the upper part of the structure to solve the problem or to find out the force in AC, or you are trying to consider the lower part of the structure. Clear? But if I take the lower part, what happen? I need to find out the external support reaction first. Then only I will get the answer. But if I take the upper part of the structure or upper part of this particular section, so it is very easy to get the answer for AC member. So let me draw this particular portion of the structure separately. Then we'll try to apply the concept of method of section. Okay. So this is the structure part which we are taking. This member is cut, this is also cut, this is also cut, and this one is also cut. Okay, now what we have, basically we have the loads 20 kilonewton and 10 kilonewton, 20 kilonewton and 10 kilonewton. Clear? And this particular length is L, this length is L, and this length is L. So can I write it down guys? This particular length is L by 2, this one is L by 2. Now we need to find out the force in this particular member, which is FAC. Okay, so how we can do it? It is very simple. What we will do guys, we'll consider joint D. This is our joint D. Let us consider joint D and take summation moment about D is equal to how much? It is equal to 0. That is very easy to get the answer. You can see here guys. Okay, so FAC into how much? This particular length is, total is L. So we'll write it FAC, which is anti-clockwise, so we'll write negative FAC into L. Okay, now this member and this member will not produce any kind of moment about point D. Clear? But what about 20 into L, which is clockwise, so we'll write 20 into L clockwise, and 10 into L, which is anti-clockwise, so minus 10 into L, and it is equal to 0. Clear? So we'll write here FAC into L is equal to how much? It is 10 L. You can cancel it. So FAC is equal to how much? It is 10 kilonewton. So the answer is basically 10 kilonewton. Answer is basically 10 kilonewton. I hope each and everyone is able to understand this particular problem guys. Clear? Okay. Now let's move to the next question, bachcha log. Let's move to the next question. We need to find out the force in member AB. Just try it once and please let me know the answer guys quickly. Okay, just try it once. I'm giving 2 minutes for this particular question to solve, and let me know the answer guys correctly, right? Which particular option is correct for the given problem. Let me give you a very simple hint also, so that you can bifurcate or you can eliminate at least 2 options directly without solving it also. Okay, let me explain. So guys, right now you are able to see this particular truss and the load is trying to apply in the downward direction. So what type of behavior it will occur? We need to find out the force in member AB. So you know that guys, if you apply the load, so the bending of the truss will be like this. That means the bottom fiber will come in tension and the top fiber will come in compression. So it is understood the force in member AB will be compressive, not tensile. If it is compressive, then which particular option can be possible? Either A or either D, right? So B and C is not possible because both are tensile in nature, right? So guys, just do it and please let me know the answer guys quickly. What will be the answer for this particular problem? Do it quickly. You need to find out the force in member AB. You need to find out the force in member AB. Tell me guys. In member AB, what will be the force? Okay, listen. Right now, guys, you can see here, this particular structure is also a symmetrical one. And we have certain external support reaction. Let us write it down. This is, let us consider V1. This one is H1. And this one is V2. Okay. Now tell me guys, right now we don't have any kind of horizontal force due to which H1 is equal to how much? It is equal to 0, sir. Now we have only vertical reaction which is V1 and V2. And if the loading is symmetry and the structure is also symmetrical, then this particular reaction will be divided, or this particular reactions are equal basically, right? Or this particular load will divide equally on both the reaction. So can I write it down guys? If this is 100, 50 and 50, that means 200. So individual reaction value will be 100 kilonewton, right? Similarly, V2 is also 100 kilonewton. 100 kilonewton. Okay, sir. Now, guys, what we will do, we'll take a section. We'll try to cut a section like this. Like this. And consider the left part of the structure. Consider the left part of the structure. Let me draw it separately so that you can understand it very well. Consider the left part of the structure. This is our vertical reaction, which is V1, and it is equal to how much? 100 kilonewton. This one is basically H1, which is equal to how much? It is equal to 0. Okay, sir. Then we have some inclined member, which is like this. Like this. Okay. Like this. This is our structure part. This is our structure part. And let us consider the force in this particular member is FAB. The force in this particular part is FAB, and there is one more load which is applied at this particular joint, which is 50 kilonewton. Any other thing? No, guys. Done. So at this particular point A, we need to find out the force in member AB, how much it is. So how we can do it, guys? It is very simple again. You can consider the moment about this particular point is equal to how much? It is equal to 0. If you write it down like this, then it means we are able to get the answer for AB part. And you can see here, guys, 1, 2, 3, and all three members are congruent about this particular point, so they will not generate any kind of moment about this particular point. Okay, so let us write it down. FAB multiplied by how much? This height is 2.7 plus 2.7, that means 5.4. Clear? These member will not produce any moment. What about H1? No moment. V1, 100 into how much? It is 3.6 plus 100 into 3.6. What about 50? 50 will also not produce any kind of moment about this particular point. So it is equal to 0. So can I find out the value of AB easily? Yes, sir. So 100 into 3.6 divided by 5.4. So what we are getting? It is coming around minus 66.67 kilonewton. Minus 66.67 kilonewton. Clear? That means A is the correct answer for this particular question. A is the correct answer for this particular problem. Crystal clear? Done. Let's move to the next question. You need to find out the force in member 1. Again, you have to use the same approach like method of section to find out the force in this particular member. Do it, guys, quickly. Do it. What is the force in member 1? What is the force in member 1? This height is mentioned, basically it is 6 meter and this one is 8 meter. Okay. And we need to find out the force in this particular member, which is 1. Okay, let us write it down. So let us consider this is VA and this one is VB. Again, structure is symmetrical as well as the loading is also symmetry. So we'll divide it equally. So this particular reaction will become 40 kilonewton and this one is also 40 kilonewton. 40 kilonewton. Now guys, what we will do, we'll take a section like this. We'll cut a section like this. And let us consider this particular portion of the structure. And you know that, guys, there will not be any kind of horizontal reaction. There is no horizontal reaction. So HA is how much? 0. Okay. So we'll try to draw this particular portion of the structure separately. Let us do it. So this is our support. Then we have inclined member, this one. Then there is some other member also. So what is this? This is basically 30 kilonewton. This is, let's consider joint A, and at joint A we have, or support A we have, VA is equal to 40 kilonewton, correct? Now let us mark the distances also. So you can see here, guys, what is this distance? This horizontal distance is not mentioned. How it is possible? Okay, they have given it. It is written in the statement. 6 meter of each span. Okay, so 6 plus 6, it is 12. So this distance is 12 meter. Okay, sir. What about this vertical height? This vertical height is 6 meter. So up to this, it is 6 meter. This one is 6 meter. Now what we will do, guys, again, we'll take the moment about this particular point is equal to 0. Moment at this particular point is 0. Consider this particular point and let us write down the equation. Summation moment about point O is equal to 0. So what we'll write, guys, exactly? VA into how much? It is 12, which is in clockwise direction. HA will not produce any kind of moment about this particular point. 30 will not produce any moment. Okay. What is this? Let us consider F1. So F1 into 6, but it is in anti-clockwise direction. Okay. What about these two member? It will give 0 moment about this particular point O. So let us write down, it is equal to 0. So VA is how much? 40. 40 into 12 is equal to F1 multiplied by 6. So if you solve this, what you will get exactly? 80 kilonewton is the answer. 80 kilonewton is the answer for this particular question. 80 kilonewton is the answer for this particular question. I hope it is crystal clear to all of you guys how to solve this. How to solve this. Correct? Now guys, I think we have discussed this particular statement or this particular concept already, right, in the starting of the class also, as well as in our method of joint or method of section. But let me explain what it is exactly so that you can take the answer correctly for this particular problem. There are two statements. One is assertion, second is reason, which is given to us. In the assertion part, what they are trying to write, in the analysis of statically determinate planar truss by the method of joint, not more than two unknown bar forces can be determined. This statement is 100% correct. This statement is 100% correct. What they are trying to give the reason as a reason, basically, there are only two equation of force equilibrium available for the coplanar congruent system. What do you mean coplanar? Coplanar means whatever forces you have, they are lying on a single plane. They are lying on a single plane like this. And if they are congruent, that means the point of application is same basically. Point of application of forces is same. That's why they are congruent. So if these two forces are congruent to each other, that means we have only two joint equilibrium equation. Summation fx is equal to 0 and summation fy is equal to 0. And this particular reason is 100% correct for the assertion part. Both assertion and reason individually correct, and it is also correlated. So guys, that's why A is the correct answer for this particular question. Crystal clear or not? Please write down in the chat box, guys. Please write down in the chat box quickly. Okay. Next question. What is the force? What is the force in the vertical member CD? You can see here, guys, you need to find out the force in this particular member, which is basically CD. How much it is? What is the force in this particular member CD? That is the question. How we can find it out? Just you need to consider joint D or joint C. That is your wish, which joint you want to take. But guys, if you consider joint C, then it is not possible to get the answer for CD member. Because if you try to resolve it, so what you will get, there are three members which will produce the component or which will produce force in the vertical direction also, right? So that's why, guys, we are not able to write down, or we are not able to consider joint C to get the answer for CD member. Clear? Second thing, you can see here, guys, this is our joint D. If we consider joint D, directly we are able to get the answer. If 5 ton is applied in the downward direction, then the same amount of force should be applied in the upward direction. And if it is upward direction, that means we are trying to pull this particular joint, or our force is trying to move away from the joint. Then such type of force is basically tension. So we can say that it is 5 ton tension force. 5T tension. Clear? Next one, AB member. Very simple. Very simple question. You need to find out the force in member AB. What is the force in member AB? Okay, sir. What is the force in member AB? So guys, again you can consider joint A directly and get the answer. You can see here, if we consider joint A, so what will happen? In this particular member, force is 0. In this member, force is also 0. But guys, we didn't discuss the concept of zero force right now, right? As well as means basically we have not discuss about this particular zero force member concept. So what we will do, guys, we'll discuss this particular part in the next class or upcoming class, how to get the zero force member, how to find it out in the question also, right? We'll discuss this particular concept in tomorrow class. But right now, guys, we will try to solve this particular question by using the method of joint only. Okay, let's do it. So these are basically two forces which is present at this particular joint A. So let us write down this force is FAB, and there is, let us consider some FAB AC. This is FAC force. Okay. Now if I write down summation Fx is equal to 0, what I will get exactly? FAB is equal to how much? It is 0. FAB is how much? It is 0. That's why D is the correct answer for this particular question. D is the correct answer for this particular problem. Crystal clear? Now this question is very nice, guys, which is related to the concept of zero force member, as well as the concept of behavior of a member, whether it is tension or it is compressive behavior, right? Okay, so let us discuss it and let us understand how to solve this particular question. I think this particular question was asked in your GATE examination already, right? Okay, let's understand how to solve it. We'll discuss it in detail. So guys, all the members of the planar truss, which you are able to see in the figure, all the forces in the truss member, which you are able to see in this particular figure, have the same properties, in terms of area of cross section, modulus of elasticity. Now, for the load shown on the truss, the statement that are correctly represent the nature of the forces in the member of the truss is, you need to tell me how many member is trying to take the tension force, how many member is trying to take the compression force, and how many member is having zero force, right? So that is our question which is given to us. Now guys, it is very easy to understand. Just you need to solve the joint first, then you will get the answer for the remaining part of the trusses. Okay, so let us try to solve this particular joint P, joint, let us consider A, and let us write down it is B. So guys, if P is applying in this particular direction, you need to apply P in this direction, right? So in this particular member, what you will find, it is tension, P tension. You have certain value of force, but it is tensile in nature. What about this one? If you consider this particular joint, there is no vertical load, so due to that reason, in this particular member, the force will become 0. How, sir? Let me write it down. Let us write F. So if you consider joint A, so what you will write? Summation Fy is equal to 0. That means minus of F is equal to 0. It means F is equal to 0. Simple. Clear? In the same way, we'll try to solve joint B also. So this one is also P tension. Clear? And this one is 0. Okay. So there are basically two member in which tension force is there, and there are two member in which right now force is 0. But guys, what about this particular member? This is also a zero force member, right? Why it is so? I will explain on the next slide. So basically there are three member which is 0 and two member which is in tension. Three member in tension? No. Two member in tension, two member in compression, one is 0. Two member in tension, one member in compression, and 2 is 0. No. Two member in tension and 3 force, 0 force member, right? So D is the correct answer for this particular problem. But let me explain why this inclined member is having 0 force. Okay, let us understand that. Guys, let us suppose if you have a truss member like this. Clear? If you have a truss member like this, and let us consider these are basically the joint of the truss. Clear? Now guys, let us suppose this is joint A and this is joint B. If this particular joint can move in either direction, whether it is horizontal or vertical, that means this particular joint will have some displacement value or deflection value. In the same way, if the joint B is also having certain displacement or deflection value, then joint B can have certain displacement value or deflection value. Now due to this reason, the length of the member of AB is trying to change. If the member length is trying to change, then definitely it will produce some force. Because we know that guys, whatever member you are trying to consider in case of truss, all the member is trying to take only axial force as an internal reaction or internal force. So guys, if some change in length of AB is present, then only the force in member AB is present. Why? Because you know that, guys, we have one relation PL upon AE or F upon AE is equal to delta. If you have certain value of delta, then only the force in the member AB is there, right? So we can write here AE divided by L multiplied by delta. If delta is 0, then force in the member is also 0. Okay, sir. Now tell me, guys, if you have a support in place of joint, right? If you have a support in place of joint like this, then due to this reason, whatever displacement of joint A and joint B is there, it will become 0 due to external support reaction. And that's why the change in length of this particular member is 0. If it is 0, can I say that the force in this member is also 0? So guys, this is the reason due to which I am writing it as a 0. So that's why 3 member is 0 force member and 2 of them are tension. So the correct answer is D for this particular problem. Clear? Next question, GATE 2015. You need to find out the strain energy in member XY. You need to find out the strain energy in member XY. Do it, guys, quickly. I am giving you 1 minute or 2 minutes. More than means 2 minutes is more than enough. You can solve this particular problem. If you understand the concept of section, method of section, you can get the answer quickly. And this is a NAT type question. And I thought this is 2-mark problem which was asked in 2015. Okay, just do it, guys, and let me know the answer correctly. What will be the answer for this particular question? Do it, guys, quickly. Force in member XY. First you have to find this. Then you will get the value of strain energy. Do it, guys, quickly. And please let me know the answer also, guys. What answer exactly you are getting after solving this particular question. Okay, let's understand this. A very simple question. If you are able to get the answer for XY member, right, that means the force in XY member, you will get the answer also for the strain energy part. So guys, what you have to do, you have to cut a section like this. Cut a section like this and try to find out the force in member XY. Try to find out the force in member XY. This is Fxy. This is Fxy. Now guys, what is this? This is basically 10 kilonewton. This one is 5 kilonewton. Correct? Now our requirement is to get the value of force for XY. So guys, if you consider this particular part of the structure, it is very easy to get the answer for XY. Just we need to write down summation Fx is equal to 0 for this particular portion. So what we will get exactly? 10 minus Fxy is equal to 0. So Fxy is equal to how much? It is 10 kilonewton. Fxy is equal to 10 kilonewton. Now you know that, guys, how to calculate the strain energy. It can be written as F square L upon 2A. Clear? So what is the value of F? It is 10. So we'll write 10 square. What is the value of L? What is the length of this particular member? It is 3. Divided by 2 AE. What is the value of AE? AE is equal to 30. So the answer is 5. The strain energy which is stored in this particular member is 5 kilonewton meter. Correct? Understood? Very nice. Let's move to the next question, which was asked in GATE 2013. You need to get the answer for RS member. You need to find out the force in member RS, how much it is. What is the force in member RS? How much it is? Please write down in the chat box. What is the force in member RS? So guys, to solve this particular question, let us consider there are two external support reaction. One is VP and second is HP at the support P. Similarly, we have VT reaction and HT reaction like this. VT and HT. Okay, sir. Now, if you consider joint V, so you are able to understand this. You are able to understand this if I draw a line like this, or this is our member. So guys, if there is certain force in member HP, then it is trying to generate some moment about this particular point. Or if this particular joint is hinge joint, then it means whatever moment we are getting from this particular part of the structure or from this particular part of the structure, it should be 0. So guys, can I write it down? HP into this particular length is equal to 0, and due to that reason HP is how much? 0. If HP is not 0, then it is trying to produce some moment about this particular point V. Clear? So let us write it down. MV is equal to 0. If MV is 0, we can write here directly HP into this length, which is 4, is equal to 0, and due to this reason HP is 0. HP is 0. Clear, sir? Now guys, we will try to write down summation Fx is equal to 0, by which we will get the value of HT. So HP minus HT plus 15 is equal to 0. Clear? So HT is equal to how much? It is 15 kilonewton. So HT is how much? HT is 15 kilonewton. Clear? HT is 15 kilonewton. Okay, sir. Now what about VT, sir? Can I find it out? Yes. Let us write down summation moment about P is equal to 0. So VT minus VT into this distance, how much it is? It is 8 meter anti-clockwise. HT into 4, again anti-clockwise direction. This 15 into 4 plus 4, 8, which is in clockwise direction. This 15 into 4, again clockwise direction. Okay. Any other force or any other reaction? No. Done. So it is equal to how much? It is equal to 0. Now tell me guys, what is the value of HT? It is 15. So 15 into 4 and 15 into 4 will get cancelled. So ultimately you will get VT is equal to how much? Again 15 kilonewton. So VT is also 15, HT is also 15. Now just we need to find out the value of this particular member RS, which will get easily. Okay. So guys, consider this particular part and let us write down this force is FRS. This is some value FRU and this one is FVU. Clear? FVU. Now guys, what I will do, I will consider moment about this particular point U is equal to 0. So we'll get the answer from this particular portion of the structure. So summation moment about you is equal to 0. Clear? So minus FRS into this particular height, which is 4, plus 15 into 4. Then guys, these two member is not producing any kind of moment about this particular point u. Similarly, this 15 will also not produce any moment. Then VT will produce some moment. So we'll write here minus VT into 4. What about HT? HT is also passing through this, right? So it should be equal to 0. What is the value of VT? VT is 15. So 15 into 4 and 15 into 4 cancel. So FRS is 0 force, right? So the force in member RS is equal to how much? It is basically 0. So the answer is 0. 0 is the correct answer for this particular question. Crystal clear, guys? Please write down in the chat box. Crystal clear to all of you? Perfect. Okay. Next question, which was asked in the GATE 2010. You need to find out the force in member QR. What is the force in member QR? So let us consider this is our reaction, which is HQ, and one vertical reaction, which is VQ. So what I will write, guys, I will write summation moment about T is equal to 0. So can I write it down? HQ minus of HQ into L plus this value is, I think, P. Yes, it is P. So P into L is equal to 0. Any other thing? P into L and HQ into L. Now VQ will not produce any movement, guys, about point D because it is passing through it. Okay. So can I write it down? HQ is equal to how much? It is P. HQ is equal to how much? It is P. So HQ is equal to P. HQ is equal to P. So the correct answer for the member QR is C. C is the correct answer for this particular question. Next question, and I think this is the last question, guys. Yes, this is the last question of the session. So let us understand this. I'm giving 1 minute for this particular problem. Do it, guys, and let me know the answer correctly for this particular question. Do it quickly. Any one of you who can give the answer for this particular question, or any doubt if you have, guys, please mention in the comment. I will try to resolve it. Whatever doubt you have, please write down in the chat box. I will resolve it, right? If you find any difficulty in finding the forces by using the method of section or method of joint, please let me know. I will try to resolve it. Okay, perfect. So let's solve this particular question. Consider the following assumptions. You need to consider these assumptions basically, right? And let's read it, whether these assumptions are correct or wrong. Let us read it. All the member have same cross section. Such type of assumption is not there in the analysis of truss, right? It doesn't matter whether the cross section area of the truss member is same or different. It is not mentioned in the our assumption part of the analysis of truss, right? The bending resistance of all the member is small in comparison with their axial force resistance. Yes, it is so, and due to this reason only we will consider the bending moment of each and every member is 0. They are not trying to take it, as well as the shear force of each and every member is also 0. So we know that, guys, due to this reason only axial force is present in individual truss member, right? And that's why the second statement is 100% correct. Next one, all the external load are applied directly or indirectly at the joint. You know that, guys, what do you mean by directly applied load, right? If you place any load directly at the joint, that means it is direct loading. But what about indirect loading? Let me explain it. Let us suppose this is your span on which some vehicle is trying to move. Some vehicle is trying to move. And let us consider, guys, our truss or bottom of a truss is placed just beyond or just below this, right? Like this. And let me complete it so that you can understand how actually we are trying to arrange our truss, as well as how we are trying to apply the load indirectly on the truss. I'm just trying to draw a small one, okay? Let us consider this is a very small truss, okay? Now guys, right now the vehicle is trying to move on this particular, you can say that the girder part, right, or the beam portion, but it is not applying any kind of load, or you can say that there is no contact between right now between this girder and the truss, bottom truss member. So how we can connect it? Let us suppose if I place a I section, if I place a I section like this, now you can understand whatever weight or whatever load is there of this particular vehicle, it will get transferred among these particular I section, right? It will get transferred among these I section, and due to which our joint will have certain load due to this particular vehicle. So such type of loading is basically indirect loading. It is not direct loading. It is indirect loading at the joints. So that's why third is also correct. Third is also correct. All the external load are applied directly or indirectly at the joints. Fourth statement says all the joints are idealized to be frictionless hinges. Yes, it is correct. If it is not a frictionless hinge, if it is not frictionless hinge, then ultimately it will try to produce some movement, or it will try to generate some friction force at the joint, due to which will not get exact axial force in the member, or you can say that there are certain other reaction also which can be present in the truss member. So that's why our hinges should be frictionless, okay? And this is an idealized condition. It is not a real one, because you know that, guys, in the real situation, what you will find, the friction cannot be 100% zero, right? So at the time of analysis, that is our assumption, this is the ideal situation what we are considering. That means the friction at the hinge should be equal to 0, or you can say that it should be a frictionless hinge. So that's why fourth statement is correct. So only 3 statements are correct, second, third and fourth, and due to which B is the correct answer for this particular question. Clear? I hope all of you are able to understand all the things which we have discussed today, right? And again, guys, those students who want to join my Telegram, you can join it, as well as you will get this particular PDF on the Telegram also, right? So guys, you can join this particular Telegram and get the link of upcoming classes. You can ask any kind of doubt if you have related to your GATE exam preparation, or GATE, right, or ESC exam also, right? So guys, this is my Telegram link, or you can directly search this particular name on the Telegram, so you will get my channel directly, okay? So this is all about for today, guys, and that's it, right? I hope you have understood each and everything which we have discussed, and thank you so much for joining the session, guys. Let's meet in the next one, where we will discuss about the null force member. So tomorrow our session will be based upon null force member. Okay guys, bye bye and take care. Thank you so much for joining it. Okay.